Okay. Now, you can take any standard or a normal curve with something having a particular mean, and then the standard deviation, depending on what that is for particular data, and you can turn it into a standard normal distribution, where you compare the mean is equal to 0, meaning the mean is in the middle of the data, 0 deviations from the mean, because it is the mean. And then this could be considered now 1 deviation to the right. And actually, we did this back in our Algebra 2 worksheet 2 weeks ago now. Not last Thursday, the Thursday before. 2 deviations, 3. So any normal distribution can be turned into the standard normal distribution scenario with the numbers meaning what they mean there. So it allows you to standardize any x value based on the mean and standard deviation, whatever the scenario may be. Not a big deal. Well, boy, there we go. All right, and I'll hold off for a second because I feel people are writing. All right, so those percentages still hold true. You know, how the data is distributed. Now we're going to go further. The other sheet that you picked up has to do with z-scores and what percentage of the data, you know, is left of a particular z-score, breaking it down to the 100th z-score. What percent of the data is to the left of a certain z-score. So again, you can take any standard deviation situation and turn it into this, and then you can compare the values using z-score for what percentage of the data is under a particular number. You know, what percentage of data is under the curve up to this number. So, cumulative area. Now, the way the worksheet works that we gave you, not worksheet, the template for z-scores and what percentage of the data is up to a certain z-score. Well, the cumulative area is close to 0 as the z-score is negative 3.49. So what this means is negative 3.49 is somewhere around here. Almost 0% of the data is left of that. We can see that. The curve is very small at that point. The area is almost non-existent there. And then, of course, we should see at 0.5, at 0, there is 50% of the data to the left of this, right? Isn't that 50% of the data left of 0, correct? Okay, so that's what the mean does. It cuts the data in half, right? And, of course, all the percentages we talked about are still holding true. And then the cumulative area is close to 1 as z gets close to 3.49. So that means 3.49 might be right here. Almost 100% of the data is left of 3.49. That's what this reads as. This is what this means. There's a Federmat. Whoops, that's not what I wanted to do. What I wanted to show you now is that chart out of my Z drive, just so you know how to read it. And actually, we could talk about that last one we just said. What did we say? 3.49, right? Well, here's how you read this, and you may remember this. Here's 3.4, sorry. And then what's on above this column? 3.4, like an 01, right? So I go up here. Yes, so 01's right here, blah, 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 all the way to 09. So how I read this is 3.49 going to this column, 0.9998% of the data is left of that. That's almost 100%, right? 99.98% of the data is left of 3.49, shaded. Okay, and we could see that in our actual note. So I'm just kind of showing you how to read this as well, because that's what today's all about. So here's 3.49, almost 100%. It was 99.98% of the data is shaded to the left of that value. That's how we read that, and that's how we read z-score. Okay, so that's what today's about. It's going to be real simple. You will walk out of here with your homework done, or you will not get a stamp. 6th hour. I don't have a 7th hour. Okay, so what I'd like you to do is sketch for these questions the standard normal curve and shade the area that they're asking. Now, we'll show the first example right here. then use your table to find that area. And I guess for the notes, we could go ahead and look at that at our sheets to try to get this figured out. So there's, a bunch of different questions we could have. Here's the first one. Find the area left of the z-score. Find the area left of 1.79. Well, now, 1.79, wouldn't you agree, is approximately right about here, right? Closer to 2. And what we want to find is this area. How much of the data is left of 1.79? Okay, so what we'll do, this one is how the chart is organized. The chart is organized that these are the areas that are left of whatever z value you're looking at. So what was it, 1.79? This is the 0.09 column right here. I wish I could show that a little bit better here. So all I have to do is go to 1.7 and then go all the way across. This is 1.70, 1.71, 72, 1.73. Get it? 1.79, I get 0.9633. So 0.9633 or 96.33% of the data is left of 1.79. And that one's done. Very simple. Then we could be annoying. Imagine that. Here comes that cough again. And find the area right of a z-score. So what's the area right of 2.03? Well, it's not a big deal here. Your chart gives you the area that is left of 2.03. So what are we going to do? Subtract it from what? Or the number 1. So I want to find that. So what I'll do, I guess I will keep going to that chart. What did it say, 2.03? Well, there we go. 2.00, 2.01, 2.02, 2.03, right here, right? So it's 0.9788, but it's going to be 1 minus 0.9788, because this is 0.9788, the yellow. All the stuff left of this. So what I want is the complement of that. So that's why I do what I do. Then the next type of question is the area between two z-scores. Ain't no thing. Chicken wings, 0.93. Negative. So I want the area between this and 2.16, which is approximately right here. What can you mathematically do to find just the area between these two? What do you think? Find both of those things. Find this. And then find what else? The other one, right? But then do what? Subtract. Okay, there's left of 2.16. I'm going to color this in blue. What's blue and yellow make? Ooh. Ooh. I don't know how great that was. Okay, and then what's the answer? The answer is what color that I really want? Only the leftover what? Yellow. Okay, so I go to my chart. You guys go to your chart. What's 2.16's area number? 0.9846. He says like a robot. And then what's the negative 0.19? The other one. You got to flip your paper over. 0.1762. Subtract them. Okay, we had a discrepancy on subtracting those numbers. It's all hashed out now. And then this one's silly. Do I have to do it? Do you get it? Find the area left of negative 1.96. So that comes right out of the chart. This ain't no thing. This is going to be fine. I guess she used the word or because what does or mean for probabilities? Well, it means what do you do with the add? Or right of 3.02, which is very small. But your chart doesn't work this way. So how do you find this one? How do you find that yellow? For 3.02, what am I going to have to find for right of 3.02? 1 minus, come on, you're killing me, Smalls. 1 minus the 3.02 number, 3.00102.9987. You're supposed to find that number and add it to whatever negative 1.96's number is. And then you add these two. 0.96 I could find. Could someone do that 1 minus? Negative 0.96, what was it? Negative 1.96, is that right? 0, 1, 2, 3, 4, 5, 6. 0.250? Well, that's nice. 00250. And then what was this one? Very small. I don't know, whatever this is, no one's answering it, and then they add them, and then you get a number. I'm done.